Good afternoon, students. Today I am going to discuss organic synthesis, unit third, formation of carbon-carbon bond principles. Several types of reaction are discussed in this chapter. Today, only two reactions are discussed. First means Aldol condensations, and second means Claisen condensations. So first discuss Aldol condensations. First contains introductions. Okay, so introduction means in the presence of strong base, two same or different molecule of aldehyde or ketones combine to form a beta hydroxyaldehyde or beta hydroxy ketones. This reaction is called as aldol condensation. Okay, simple definition: in the presence of strong base, that is sodium hydroxide, NaOH, two same or different molecule of aldehyde or ketone combine to form a beta hydroxyaldehyde or beta hydroxy ketone. This reaction is called as the Aldol condensation. Okay, any problems? Next, Aldol condensation, a property of a carbonyl compound having hydrogen at alpha carbon atoms. Alpha carbon atoms. So, the example means acetaldehyde, propanaldehyde, aliphatic aldehyde, or aromatic aldehydes. But in case of formaldehyde, does not example of aldol condensation because alpha hydrogen atom does not present in these examples. First is acetaldehyde. This aldehyde group as a functional group. Then neighboring carbon atom, these alpha carbon atoms. Okay. Next, aldol condensations. Aldol means aldehyde and alcohol group on the same molecules. These aldol are distributed in two parts. ALD, ald means aldehyde, OL means alcohols. Okay, may occur between two aldehydes, aldols, or ketones in the presence of catalytic base like sodium hydroxide. Okay, then a reaction is only possible between two components. Reaction is only possible between two components having alpha hydrogen, having alpha hydrogens. Suppose last product beta hydroxyaldehyde, beta hydroxyaldehyde. So right hand this compound means CHO. It is a functional group, aldehyde functional group. Next carbon atoms alpha position, then next carbon atom beta position. So this beta carbon atom is directly attached. OH group means alcoholic group, hydroxylic group, that is called as beta hydroxyaldehyde. Okay, next aldols. And aldols or aldol adduct from aldehyde alcohol. Okay, aldol adduct means aldehyde alcohol is a hydroxy ketone or aldehyde and is the product of aldol addition as opposed to aldol condensations, which produce an alpha beta unsaturated carbonyl moiety. Alpha beta unsaturated carbonyl moiety. Alpha beta, that is the Greek positions, unsaturated carbon carbon double bond, that is called as unsaturated carbonyls, C double bond O, that is the carbonyl group. Okay, alpha beta unsaturated carbonyl moiety. When used alone, the term aldol may also refer specially to the compound 3-hydroxybutane like this. Okay, in right hand side R1, R2, R3. So left hand side second carbon atom means alpha position. Sorry, second carbon. Sorry, right hand side R3, the neighboring carbonyl group. Okay, these are ketonic group or carbonyl group. Then R2, this carbon atom alpha. Then next beta. So beta carbon atoms is directly attached hydroxyl group or alcoholic group. Okay. So next, aldol condensations introduced generally. The aldol condensation reaction is an organic reaction introduced by Charles Woods, introduced by Charles Woods, who first prepared who first prepared beta hydroxyaldehyde from acetaldehyde in 1872. Okay, first prepared the beta hydroxyaldehyde from acetaldehyde in 1872. लक्षात म्हणजे सर्वात पहिला बीटा हायड्रॉक्झी कोण तयार केला असेल फ्रॉम acetaldehyde which year 1872. Next point, two molecules of an aldehyde or ketones. Simple example, acetaldehyde or acetones. Aldehyde means acetaldehyde, ketones means acetones or dimethyl ketones. Undergo a condensation reaction. Undergo a condensation reaction in the presence of a base, that is the sodium hydroxide. Previous slide I will discuss. To yield beta hydroxyaldehyde or beta hydroxy ketones. Suppose you have choose two acetaldehyde react with each other in the presence of base, gives product beta hydroxyaldehyde. Okay, then two reactants, that is acetones, dimethyl ketones, acetone or dimethyl ketones react with each other in the presence of strong base, gives beta hydroxy ketones. So any problems in these reactions? Anybody problems? Next, general aldol condensation reaction. General aldol condensation can be defined as an organic reaction in which enolate ion react with carbonyl compound to form beta hydroxy ketone or beta hydroxy aldehyde, followed by dehydration to give a conjugated enol, means unsaturated bonds generally. So what is meant by dehydration? A removal of water molecule, that is called as the dehydration. Next point, aldol condensation plays a vital role in organic synthesis, creating a path to form carbon-carbon bonds. So chapter name carbon-carbon bond formations. Okay. Next, the general reaction for aldehyde and ketones. First point important, general reaction for aldehyde and ketones. For aldehyde and ketone containing alpha hydrogen. This alpha hydrogen atom is most important in this example. So first example, acetaldehydes, that is the hydrogen ethanol in the presence of strong base dilute NaOH gives first 3-hydroxybutane, that is aldol. Simple name beta hydroxyaldehyde. Right hand side is CHO aldehyde group. Next carbon atom alpha position. Next carbon atom beta position. So next beta position is directly attached OH group, that is called as beta hydroxybutene or beta beta hydroxyaldehyde or 3-hydroxybutene, that is the IUPAC. Then these 3-hydroxybutene on dehydration, that is the water molecule remove, then formation of carbon carbon double bond. Name is but dash to enol, that is the alpha beta unsaturated aldehyde. Right hand side CHO, that is the aldehyde group. Next carbon alpha, next carbon beta. Alpha beta carbon is directly attached carbon carbon double bond, that is the unsaturated. Okay, aldol condensation products. Any problem is aldehyde means aldehyde examples. Next examples, ketones. Example, ketones. That is the example of propanone. Simple example. No, ketones, propanone. In the presence of barium hydroxide, first gives ketone. First gives ketone. That is the IUPAC name 4-hydroxy, 4-methyl, pentane, pent dash 2-ONE. That is the IUPAC name. So you have choose the chain in right hand side. First carbon atom CH3, second carbon atom C double bond, third carbon atom CS2, fourth carbon atom C. So fourth carbon atom is directly attached downside OH, that is the hydroxy, upper side CS3 alkyl groups. Okay, that is the name methyl. So chain R you select 5 carbon atoms, that is the 5 carbon means pentane. Then here OH group is directly attached 4 carbon atom. So alkane last E is replaced by ONE. Last E is replaced by ONE. Okay, then give the name 4-hydroxy 4-methyl pent dash 2-ONE. 2-ONE. 2 means position, functional groups near carbon. Okay, these 4-hydroxy 4-methyl pent dash 2-ONE on dehydration. On dehydration, that is the main product 4-methyl pent dash 3-EN dash 2-ONE means aldol condensation product. Okay. Next, any doubts, any problems? Yes, student. Next point, mechanisms. Next point, mechanism. 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 There are 5 steps in this mechanism. Step first, formation of carbanion. Step second, nucleophilic attack or nucleophile attack. Step third, protonations. Step third, protonation. Step fourth, my mistake, typing mistake. Step 4, hydrolysis. The step 5, dehydration. Okay, sorry, my mistake. Third steps 2 times I will return. Okay, you can understand. So one by one steps are explained. Formation of carbanium first. So you know what is the carbanium? You know, yes, carbanium. Carbanium is a species in which carbon atom is negative charge. Okay, carbon atom is negative charge. So first step first. In reverse order, the hydroxide ion deprotonates the aldehyde. Okay, so first aldehyde acetaldehyde CS3CHO is react with base hydroxide ion, which means negative charge. Okay, then reverse order. So first, this alpha hydrogen atom of aldehyde is abstract or removed by OH by OH, that is removal of water. Then here you have formed enolate ion or carbanion CS2 one lone pair negative charge CHO, that is the carbanion. Any problem? Step first. Step second. Here step second, nucleophilic attack, nucleophile attack. Here enolate ion or carbanion one add to the unreacted aldehyde. What is nucleophile? Nucleophile is a species in which more electronegativity, more electron density or negative charge. Okay, so unreacted aldehyde, that is the another aldehyde acetyl, is attack on carbanion or enolate ion. Reverse order gives alkoxide ion, gives alkoxide ions. Any problem? Nucleophilic attack, nucleophile attack. Step third. Step third, alkoxide ion is protonated by water. Alkoxide ion 2 is protonated by water. So alkoxide ion is protonated by water. This is 2. Reverse order gives beta hydroxyaldehyde in aldol, means beta hydroxyaldehyde. Right hand side function, next carbon alpha, next carbon beta. So beta carbon atom is directly attached. O is that is the beta hydroxyaldehyde. Hydroxyaldehyde removed. Step third. Then next steps fourth. A small amount of aldol is converted into enolate ion 4 by hydroxide. Simple steps. A small amount of aldol means beta hydroxyaldehyde. Okay, is converted into enolate ion. Enolate ion, that is the 4 by hydroxide ion. So these beta hydroxyaldehyde, these react with hydroxide ion. Reverse order gives enolate ions. Enolate ions. So here enolate ion. Here alpha hydrogen atom is removed by OH attached. So removal of water. Then last step. Here enolate ion in bracket 4 loss a hydroxide ion. Loss a hydroxide ion. Okay. So here CS3, CH, OH, CH, CHO. These are intermediate steps. Reverse order. Then gives OH, nuclear OH means hydroxide ion is removed. Then formation of alpha beta unsaturated aldehyde. Alpha beta unsaturated aldehyde. This example CS3 CH double bond CH CHO. Right hand side CHO. Next carbon atom alpha. Next carbon atom beta. Alpha and beta carbon atom carbon carbon double bond. That is the alpha and beta. Okay, alpha beta unsaturated aldehyde. And nucleophile is removed. Any problems? Okay. Next. In Aldol condensation, there are two types of mechanism. One is base catalyze, another is acid catalyze. So first is base catalyze. First is base catalyze. So first example, CS3 CHO acetaldehyde base catalyze is react with OH, then gives carbene, removal of alpha hydrogen, removal of alpha hydrogen, removal of alpha hydrogen on one hydrogen atom of an one hydrogen means alpha hydrogen atom is removed by or abstracted by OH. Then water molecule remove the formation of carbene in these steps. Step second, nucleophilic addition reaction. That is the base catalyzer organization. Okay. So these another acetaldehyde again attack on carbanium, then gives alkoxide ions. Okay. So negative. Yeah. Remaining similars attached. Here CS3CH double bond O. This O is highly electronegativity is downside or upper side is negative charge. Then carbanium is directly attached positive charge delta positive. This CS2. Okay. Step third, protonation of alkoxide ion. In above step, this product means alkoxide ion. What is the protonation? Addition of proton. Simple definitions. You know. So these alkoxide ion on hydrolysis gives beta hydroxyaldehyde and remove OH negative in step third. Then last steps, dehydrating of product to form alpha beta unsaturated aldehyde. Alpha beta unsaturated aldehydes. So these beta hydroxyaldehyde, that is the product, is again react with OH negative. So gives alpha beta unsaturated aldehyde. Here dehydration is removal of water molecule. Here beta position is directly attached OH remove, then alpha here CS2 one hydrogen atom remove, then here HOH is removed S2, that is the formation of alpha beta unsaturated aldehyde. Okay, one hydrogen atom is alpha position is removed, one OH molecule in beta position is removed, that is the combination of water molecule is removed. Okay, mechanism of Aldol condensation. Second here, acid catalyze Aldol condensation. Simple acetones. Okay, examples CS3C double bond CS3. That is the protonation. Reverse order gives CS3C double bond OH here CS3. Each H positive is directly attached oxygen, highly electronegativity. Step second, formation of enol. Formation of enol. So here reverse order. So here water molecules gives here alpha beta here water molecule remove. Water molecule remove means H here H HCS2 OH CS3 is first CS3 C double bond OH positive charge bond CS3. This positive charge means double bond. This double bond remove OH, that gives here H. So S2 is attaching H here S3O. So one hydrogen atom is removed by OS S2. That is the formation of S3. Step second and last step, attack of protonated carbonyl group of a second ketone molecules. That is the hydrolysis general reactions. Okay, here CS3 C double bond OH CS3 CS3 C double bond O CH3. Then last product CH3, here C CH3 OH CH2 C double bond O CH3 plus S3O positive. S3O positive atom of protonated carbonyl group of a second ketone. Second ketones means simple. Second ketones means acetones or dimethyl ketones. Then next point, crossed aldol condensations. Crossed aldol condensations. Condensation reaction between two different molecules of an aldehyde or ketone in a protoic solid, protic solid, such as example water, alcohol. That is the word protoic solid. Constitutes the cross aldol reactions. Simple sentence. The condensation reaction between two different molecules of an aldehyde or ketone in a protoic solid, such as water or alcohol, constitute the cross aldol condensation. Next point, when condensation is between two different carbonyl compound, okay, it is called as cross aldol condensation. Simple point. When condensation between two different carbonyl C double bond C double bond, but different carbonyl compound, it is called as cross aldol condensation. So first example, CH3 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 C double bond H, that is the aldehyde, okay, plus acetone or dimethyl ketone in the presence of base. In the presence of base gives beta hydroxy aldehyde. Beta hydroxy aldehyde. Okay, that is called aldol condensation. But cross aldol condensation. So cross aldol condensation, simple example, acetaldehyde, propanoldehyde. Simple example. You know, or you see. Next, here aldehyde means tertiary aldehyde, CH3, CH2, acetaldehyde, different aldehyde. Or next example, aldehyde means benzaldehyde and means acetophenol, benzene plus C double bond O CH3 in the presence of strong base OH at 293 Kelvin gives like this product. Name benzal acetophenol, that is the major product. Hmm? Example 1 and 2 in bracket, cross aldol condensation with aldehyde and ketones. Any problems? Next, mechanism of cross aldol condensation. Cross aldol condensation. Step first, deprotonation and formation of nucleophile. Simple acetaldehyde in the presence of strong base gives this alpha hydrogen atom is abstract or removed by OH, then removal of CH2 and formation of carbanium. Step second, attack by nucleophile, formation of alkoxide, formation of alkoxide ion. So here is benzaldehyde. Another aldehyde means benzaldehyde. You can example of crossed aldol condensation. First aldehyde acetaldehyde step first. So step second benzaldehyde, that is the different aldehyde. Okay. This benzaldehyde is directly attack on, or this carbanion ion is directly attack on carbonyl compound. Which carbonyl compound? It is the example of benzaldehyde carbonyl compounds. Okay. Then formation of alkoxide ion. So benzene ring CH, upper side O negative, downside CH2 CH2. Okay. Then step third. Step third. Step third. Mechanism continues. Step third. Hydrolysis and formation of aldol type product. This alkoxide. on protonation, generally on protonation of water, that is the OH. Here O negative is directly attack on H positive protonation, then OH negative remove. So benzene ring CH, OH, CH2, CH2. Then last steps intermolecular dehydration. Generally, definition of dehydration removal of water molecule. So here upper side OH negative, then downside alpha position, one hydrogen is directly attacked OH negative, that is the removal of water molecule. Yeah, final product cinema halide. So any problem in this mechanism, simple Aldol condensation mechanism or crossed Aldol condensation mechanisms, any problems? Yes, anybody? Okay, so next, Claisen condensations. Second reaction, Claisen condensations. Here, minimum, here you see contents. First is history, second is general principles, third is requirement for the reaction, fourth is mechanism of reactions, fifth example, most important cross Claisen condensation, the last intermolecular Claisen condensation. Okay, one by one contents are explained. Claisen condensation means acid to acetic ester condensation. So here N L Claisen O Lohmann Bell 26500 in 1887. These are volume, these are page number, then 1887. So simple point. Base catalyzed condensation of an ester containing an alpha hydrogen atom with a molecule of the same ester or a different ester. Want to give beta keto ester. It is the most important. You have choose same ester or different ester. No problem. But in product beta keto ester, these are your mind are set up beta keto ester. Okay. So example here, example same ester or simple ester, that is the ethyl acetate react with each other in the presence of ethoxide C2H5O negative, then gives here one ester is directly attached CS3. So one hydrogen atom is directly attacked on ethoxide, that is the removal of ethyl alcohol, their main product beta keto ester. Suppose right hand side you have choose functional group COO ester. Okay, then neighboring CS2, that is the alpha position, near beta position C double bond carbonyl group. This beta keto means carbonyl compound C double bond. Okay, then ester, then removal of CPH5. Any problem? Next one, general principle. General principle. The Claisen condensation reaction is an organic coupling reaction that results in the formation of a carbon-carbon bond. The formation of a carbon-carbon bond between either a single ester and one carbonyl compound or between two esters. Again repeat, the Claisen condensation reaction is an organic coupling reaction. First, that result in the formation of carbon-carbon single bond between either a single ester and one carbonyl compound or between two esters, one or two esters. Next, the reaction proceed in a strong base, that is NaOR, sodium alkoxide, sodium alkoxide is present, and the product of the reaction is beta keto ester or beta diketones, beta keto ester or beta diketones. Okay, so here are two examples. Ester react with each other in the presence of strong base gives beta keto ester. Here similar, right hand side R dash. Okay, then here O double bond O, that is the ester. So next carbon alpha, next carbon beta. So beta position is similar. Beta keto ester. Then alcohol is removed. Okay. Next requirement for the reaction. At least one of the reagent must be analyzable, have an alpha proton, and be able to undergo deprotonation to form the enolate anion. Anions means negative charge. Okay. The base used must not interfere with the reaction by undergoing nucleophilic substitution or addition with a carbonyl compound. Nucleophilic substitution or addition with a carbonyl carbon. For this reason, the conjugated sodium alkoxide base of the alcohol form, example sodium ethoxide, if sodium is formed, is often used since the alkoxide is regenerated. Regenerated. Another requirement is that the alkoxy part of the ester must behave as a good living group, as in case of ethyl and methyl ester. Ethyl and methyl ester. Next, mechanism of reaction. Mechanism of reactions. So here step first, enolate formation. Enolate formation. The mechanism of Claisen condensation beginning with the formation of the ester enolate ion. Ester enolate ion. Next point. The ester is the first. The ester is the first deprotonated. Is removal of proton in the alpha position. Same point, Aldol and Claisen. The ester is the first. This ester is first deprotonated in the alpha position to form a resonance stabilized enolate. Okay, so first ester, one proton is deprotonated by RO means alkoxide, that is the removal of alcohol. Then here enolate formations. Okay, any problem in these steps? Repeat. I will discuss. The ester is the first deprotonated, means one proton remove or abstract in the alpha position to form a resonance stabilized enolate. Then removal of ROH, then alkoxide means enolate formation. Step second, nucleophilic attack. Then this enolate functional as a nucleophile and attack another molecule of the ester, forming a tetrahedral intermediate. Okay, so first these are first step products. Enolate is attack on another molecule of ester, ROC double bond OCS. Okay, these directly attach means alkoxide enolate ion is directly attached on another molecule of carbonyl compound of ester. Okay, so this enolate function as a nucleophile and attack another molecule of the ester, forming a tetrahedral intermediate. Tetrahedral intermediate. Okay, then step third. removal of leaving group. Removal of leaving group. In the next steps, the tetrahedral intermediate expel means second step product. Okay, the leaving group to reform a carbon oxygen double bond. Carbon oxygen double bond. Okay, then removal of leaving. Removal of leaving group is OR. OR here. Here left side COR. This OR is leaving group are removed. Okay. Then next examples. Next examples. General Claisen condition reaction ethyl acetate in the presence of sodium ethoxide gives beta keto ester. Then ethanol remove. You know previous slide. Okay. Then next point, crossed Claisen condensation. Claisen condensation between different ester reactor. Different ester reactor. First means phenyl acetate, another is methyl acetate. That is the different ester reactors. Okay, are called as cross Claisen reaction. Two different ester are react with each other. That is called as crossed Claisen reaction or condensation. Okay, and phenyl acetate is react with methyl acetate in the presence of sodium methoxide NaOCS3, then gives same product beta keto ester. Beta keto ester. Here one proton is abstract by is abstract or removed by CS3OH, means CS3OH. Okay, any problem here? CS3OH, and methanol is removed. Then next, intramolecular Claisen condensation. Diester, okay, can undergo an intramolecular reaction called a Dieckmann condensation. Dieckmann condensation. So here two join esters. For example, two join ester with hydrogens. Wait, suppose N, here bracket in N is equal to 1, 2, 3, dot dot dot. So here M, capital M is equal to Li, Na, K is lithium, sodium or potassium. So use cyclic beta keto ester. Cyclic beta keto ester. Two join esters in the presence of MOR oblique ROH acid workup that give cyclic beta keto ester. Another example of intramolecular Claisen condensation. Claisen ester condensation mechanism part 1. So first here ethyl acetate is react with ethoxide. It is a fast step reaction or process that gives here right hand side one proton is abstract or removed by ethoxide ion, then gives ethyl alcohol remove, then formation of enolate. Here CS2 negative charge, C double bond O, OC2H point. Okay, then these are enolate ionized resonance gives CS2 double bond C. These bonds are shifted here, oxygen. So CS2 double bond C, C here O is negative charge, that is the valence is incompleted because oxygen is valence 2, that is the negative charge. Then bond OC2H5 enolate ion. Okay. Then second, one is acceptor or one is donor. So first is CS3C double bond OC2H5 ethyl acetate is acceptor. Another is CS2C double bond OC2H5. These are carbanion. Okay, these are donor. It is a slow process. So gives CS3C single bond O. Here OC2H5. Here CS2 attached here. That is the main product of here enolate ion. These enolate ion are donor, and then another molecule of ester means ethyl acetate is acceptor. in the slow process or slow reaction that gives this product. Next, part 2. So here same, these previous product means second step product, here fast process. Then here remove of ethoxide remove CH3C double bond O, double bond O. Here ethoxide are removed, then C double bond O. Here near downside CH2 C double bond O C2H2. Okay, it is the first process. Then next example, cross Claisen condensation example. So previous slide you discussed, one is acceptor, one is donor. So here acceptor is aromatic ester and donor means aliphatic ester in the presence of same sodium ethoxide NaOCH3CH2 CH. Then here same product in previous slide, benzene ring C double bond O CH2. Here same one proton is abstract or removed by ethyl alcohol, then gives this product. So next, cross Claisen condensation. In the cross Claisen condensation, we have choose one of the ester to be acceptor. One ester is acceptor. The another ester is donor. First you have discussing acceptor. The acceptor does not have alpha hydrogen atom. Suppose कसं असते ज्यात दोन इस्टर तुम्ही चूज केले डिफरंट किंवा सेम, त्याच्यामध्ये जो ऍसेप्टर इस्टर आहे तो तुमचा अल्फा हायड्रोजन ॲटम डज नॉट हॅव, म्हणजे अल्फा हायड्रोजन ॲटम नसतो. बट इन केस ऑफ अनदर इस्टर डोनर डज हॅव हायड्रोजन असतो, मीन्स अल्फा. इट कॅन react with base, that is the it can react with base to form nucleophilic enolate ion, to form nucleophilic enolate ion. With such an experiment, design the cross Claisen condensation can be used successfully. Most important 2 points. One ester is donor, one ester is acceptor. So acceptor ester does not have alpha hydrogen, but in case of donor ester does have hydrogen. Okay. Next. Thanks.
ऑडिओ हे करण्याच्या व्हिडिओ तयार कसा करायचा?